we are learning about the hyperbola. It is our third conic. The hyperbola looks similar to two parabolas facing opposite directions. That's not what it is, but that is how it looks. By definition, a hyperbola is a set of all points in a plane where the difference of the distances from two fixed points is constant. With an ellipse, it was the sum. It was the sum of those two fixed points. With a hyperbola, it's the difference that is constant. Once again, those two fixed points are called foci. The foci are always located inside the hyperbola. All right, hyperbolas can open two ways. Well, we are going to study two ways that hyperbolas can open. They can open more than that, but we're only looking at ones that open horizontally and ones that open vertically. Okay? If they open horizontally, look what comes first. X. The X is positive when it opens horizontally. And that's why we put it first. Okay? When it opens up and down, the Y comes first. The Y is positive when it opens vertically. Okay, so these are our two standard forms. You're going to notice they are very similar to the ellipse, which makes sense because by definition, they're a difference between two fixed points. The ellipse was a sum. Look at the only difference in the formulas. The difference equals 1. The difference equals 1. So the formula looks just like, exactly like. Ryan? No, sir.
Just stop being mature.
An ellipse except for the minus. Okay? So that's the first thing we have here. What are some similarities and differences that you notice between the hyperbola and the ellipse? The formula looks very similar. The standard form is very similar. The only difference is that it's subtraction.
Warning. Morning.
We'll get it. I'm not open.
Shut up, Ryan. I don't care. I'm not talking, so he's alright. Warning. Warning.
No, they're not there. So I want to see what you would do, what you were thinking.
No, stop talking.
Okay. Okay, so how do we tell if it's horizontal versus vertical? What did we just say? Okay, with horizontal, the X is positive. With vertical, the Y is positive. Okay, so because it's positive in standard form, the X comes first. Because it's positive in standard form, the Y, when it opens vertically, comes first in the equation. Now, if I gave you an equation that wasn't in standard form, the X may not be first when it opens horizontally. You might have to do some work and determine which one comes first. So the X comes first in standard form. The Y comes first in standard form. So if I give you one that's already in the standard form, where you don't have to complete the square or anything. If the x comes first, opens left and right. If the y comes first, opens up and down. Okay? All right. So, we're going to identify the parts in the formula and how they relate to the equation. The center is still going to be HK. So this one's opening left and right. It would be this standard form. Okay, and once again, this A and B is going to flip-flop depending on what's what. You don't really need to know A and B. You need to know this is the horizontal move squared. This is your vertical move squared. Okay, so to find our vertices, if it opens left and right, the vertex is actually part of the curve. That's the one piece of this graph that's part of the curve, is our vertex. So if it opens left and right, to find the vertex, we're going to add and subtract that A to the X at the vertex. So for example, if I had this equation, I'm going to change colors and we'll put our example out to the side. So if it were x minus 3 squared over 16 minus y plus 1 squared over 9 equals 1, the center would be what point?
3, -1.
3, -1. Because the x is positive, the x comes first, we know it opens like this, horizontally. So we would find this horizontal move. How far would I move left and right from the center to find those vertices? 4. So I'd go left 4, which would be -1, -1. I would go right 4, which would be 7, -1. Those are my vertices, just like these. Okay, now, then we have to create our asymptotes. The asymptotes are what form the graph. The graph rides along the asymptotes. And the way we create the asymptotes is really simple. We always do, for a line, these are lines, we always do rise over run. Rise over run to graph a line, don't we? Slope. So to find the rise over run, what we do is we look for the move under our y, that's our rise. Y, up and down. The move under our x, that's our run. So in this case, our asymptotes would be this slope. That would be the positive one. How would I get the negative one? It's always plus or minus. So in standard form, it looks like this. Y minus k equals plus or minus rise over run, B over A, x minus h. It's rise over run though, because the A and B swap places depending on how it opens. That's why I don't always like A and B. All right, got a new little bit of vocab here.
Wait, can we
Transverse axis connects the vertices.
Miss Wood,
Yes.
can you write the equation for the purple formula?
Oh, yes, for the purple formula, thank you, it would be y minus -1, so it's y plus 1, equals plus or minus rise over run, under the y, under the x, 3 over 4, and then x minus 3. Thank you, I skipped that.
Wait, x plus 3?
It's x minus 3,
Oh,
because it's
minus
x
3?
minus that, yeah. Yeah. All right, so transverse axis, that's a special name for the one that connects, if we connected the vertices. Okay, so transverse axis is this one right here. So if this is A and this is A, the transverse axis would have a length of 2A. The conjugate axis is the other one. We don't really have co-vertices. Do you see that this point right here and this point right here have absolutely nothing to do with the graph? It helps us form the box, which is important. We're going to do one of those in a second. So the conjugate axis is basically the other one, the other axis. And its length is 2b. This and that. Now, do you see how the foci are outside? They are outside of the box. It is further than A. With the ellipse, to find the foci, we said that C was the square root of A squared minus B squared. That's what pulled it inside. This one's going to be A squared plus B squared. That pushes it outside, which is where the foci lie. If we subtracted it, it would bring it in. Okay, so the foci, when it opens horizontally, we still are going to add and subtract this C to our X value at the center. If it opened the other way, we would add and subtract it to our Y. But C is found differently. C is the square root of A squared plus B squared. That's the only way to push it outside. Okay, so here's one, and we're going to go through it step by step. What do? So we're going to look at a couple. The first thing we always find is the center, just like we did with the circle, just like we did with the ellipse. So really, same kind of stuff. So we're going to start with the center.
0, 0.
0, 0. Very good. All right, then we have to decide, is this going to open left or right, or is it going to open up and down, horizontally or vertically?
Horizontally.
Horizontally, because the X is positive and came first in standard form. So we know it's going to go this way. So we're going to keep that in mind. We're just going to make our brain remember this one's going this way because X is positive and it came first in standard form. All right, so now we're going to do those horizontal moves. And horizontally, I would move how far? What is A? 4. So I'd move 4 units this way, 4 units that way. Those are the vertices. This is actually part of the graph. Now I'm going to switch colors. Well, I said I was. Now Moby's with me. So vertically from the center, I'm going to move 3 units. This point is not part of the graph. What this point does is it helps me to create a box. And if I take that box and go through the vertices of the box, which is really hard for me to do on the Moby. That wasn't bad. That is one of the asymptotes. And then I'll do it again. I'll draw this one in this way. There's my other asymptote. Good enough. Okay, so let's see. On this asymptote, rise over run. The number under my y over what's under my x. 3 over 4. 3 over 4. That should be my slope. Let's count the slope. Up, 1, 2, 3. Right, 1, 2, 3, 4. Yeah. And then this one is just the negative of that. So that is how we get our asymptotes. Now, once you have your asymptotes drawn, all you do is you go to your vertices and you just follow along the box and the asymptote with your curve. And we know it has to go left and right. We figured that out to start with. So it just rides along the asymptote. And there's a hyperbola.
So easy.
Yeah. Okay, so let's go through. We did the center. Our vertices were those 4 units this way, 4 units that way. So our vertices were at plus or minus 4, 0. And we can write it like that because they're just opposites of each other. The asymptote, y minus the y value at the center, plus or minus the rise over the run, x minus the x at the center. Do I really need the zeros? No, but if that point were anywhere else, you would definitely want to write it that way. Now, foci. Okay, so foci, first we have to find C to find our foci, because it's going to be the x value at the center plus or minus C, 0. So what is C for this problem? It is the square root of 4 squared plus 3 squared. 16 plus 9 is 25. Okay, this doesn't happen often. Usually this is just a radical we can't take the square root of. This time it works out really pretty. C is 5. So the foci, guys, on this problem, we could actually graph. There's one right here at positive 5. There's one right there at negative 5. The foci on this problem are located at positive and negative 5, 0. Usually they're going to be like 0 plus or minus some crazy square root of 37 or something weird. All right, let's do some more. Okay, the first one. Y comes first, it's in standard form, and Y is positive. How will this one open? Vertically. Okay, when Y comes first, it messes with our brain because we're so used to X coming first. So we have to be careful. On this one, it's not as hard. On this one, it is. When we go to write the center on number 3, the center is actually 2, 1. And it messes with our brain when Y comes first. We sometimes try to write that Y first when it's not first in an order pair. X always comes first. All right, but number 1, the center is what? You tell me. 0, 0. Okay, plot it. We already said because the Y comes first, it's in standard form, and the Y is positive. We know this one's going to open how?
Vertically.
Vertically. Okay, so how far do I go up and down 2 to find the...
2.
Yes. Makes it easier when I tell you the answer. You go up and down 2 from the center to find your vertices. So we go up 2, we go down 2, vertices. Boom. So that transverse axis, that's the one that would connect the vertices. It was up 2, down 2. What's its length?
4.
Yes. Okay. The conjugate axis, not part of the graph, but we need it to draw the box. So the conjugate axis, if I look at this, what is the square root of 16?
4.
4. So that tells me left and right, I move 4. The conjugate axis has a length of what?
8.
8. Now I draw my box. Okay, now since it's actually not part of the graph, I make it a little dash line. It's not, it is important, but it's not important. It's kind of like the middle child.
Hey.
Oh, thanks.
I'm just teasing. Middle children are super special.
The middle child.
Super special.
I'm the middle child.
Because you're not the favorite, but you're also not.
I don't know. I have noticed that middle children tend to be the easiest.
That is not the case.
No, they tend to be very Easy to get along with, easy going.
Wait,
It's awesome. Alright, so
You're just making up because you
You
wanna
just-
know all of them.
do that little box and draw in your asymptotes. 4 and 4. All the way across.
Miss Willoughby, someone's going to be listening to this on Willoughby World of Math, and they're going to unsubscribe to you because you said that.
I know.
When you ask subscribers, you have to.
I have to be a little more politically correct. Alright, so now we can actually draw it in. It's going down the asymptotes, following the asymptotes. Alright. There we go. There's our graph, opening up and down, following along the asymptotes. So now it's asking, what is that equation for the asymptote? Y minus the y value. Rise over run. Rise is 2, run is 4. Y over x. 2 over 4. What does 2 over 4 reduce to, folks? 1/2. So plus or minus 1/2 x minus 0. Now, you really could just write y plus or minus 1/2 x, because the zeros don't really matter. I just want to get us used to using our center. Okay,
Question.
yes.
Why did you put for the vertex plus or minus 2, 0 instead of instead of 0 plus or minus 2? Since it's y.
Oh, you were right. I did that wrong. The vertices are 0 plus or minus 2. You're so right. Good catch. Sorry, everyone.
Just we didn't notice.
Okay, number 2.
Look at your vertices.
Will it open? Vertically or horizontally? Oh, I'm missing the foci. Sorry, foci. We got to find C. What is C? C is the square root of a squared plus b squared. So we just add the denominators. What is 4 plus 16? 20. Now, I won't count off if you leave it square root of 20, but those of you that plan to take the SAT need to know that square root of 20 is 2 roots of 5, right? They will not leave anything unsimplified on the SAT or the ACT. So if it's the no calculator portion, does the ACT have a no calculator portion?
Yeah.
Yeah? Okay.
Yeah.
All right,
In the
so,
SAT, you didn't need the calculator in the calculator section, but you needed it in the non-calculator section. Like, I didn't use it at all in the calculator
yeah,
how it works.
they're probably testing stuff like this. All right. So plus or minus 2 roots of 5, because, once again, because it opens vertically, they get pushed out here up and down. So you have to add it to your y.
How would you graph that?
2 roots of 5, I wouldn't. It's like 4-ish, a little bit past 4-ish.
How do we know that though?
Because the square root of
2
16
squared or marked.
is 4, and the square root of 25 is 5, and the square root of 20 is in between those two. So it's a little past 4, a little before 5. That's how we would know.
It's the flow is 0.
Plus or minus 2 roots of 5. Okay, number 2. Where's the center?
3 negative.
The center is 3, negative 1. 3, negative 1. Okay, will this open vertically or horizontally?
Horizontal.
Horizontally. So how far do I move to find my vertices? 3. So I go 3 right, 3 left. I see them. My vertices are the points 0, negative 1, and 6, negative 1. Which means my transverse axis, I went 3 and 3. 3 and 3 is 6. My conjugate axis. How far do I move up and down to create that conjugate axis? I move 5.
So it's 10.
So 2, 4, and then, there we go.
It's a big one.
So it's 10. So the conjugate axis can certainly be larger than your transverse axis. Okay, now we create our box. Now, eventually some of you guys are going to get to where you don't do the whole box. You just do these points in the in the corners, and that's cool too. And then we draw in our asymptotes. Good enough? Nowhere near. All right. Okay, so because this opens horizontally, these are the 2 points that start to form the hyperbola, and this one's like flattened out. So those asymptotes that we just created are y minus the y value at the center, so minus the negative makes a positive. Rise over run, our y move over our x move. So plus or minus 5 over 3, y over x, vertical over horizontal. That's what slope is. And then x minus the x value. Leave that in that form. Do not put it in slope-intercept form. Leave it in point slope. All right, so now we have to find C so that we can do the foci. So C, well, maybe you went a little nutso.
Whoa.
It's going to be the square root of 9 plus 25, and it gets added this way, left and right. So our foci would be the points 3 plus or minus square root of 34, which does not simplify, comma, negative 1. That's the location of the foci. So that would be, this is really close to 6. So
Would we
it
have
would,
to know that?
no.
Okay.
All right, so you try number 3.
Oh, don't get tricked. Just bad reading.
Okay, so this was a vertical one. The trickiest part is writing down your center correctly, and we kind of talked about that a second ago. 2 is your x. 1 is the y. Did you catch that?
Yeah.
2, 1. Good. And not as good, but good for those of you that caught. All right, so 2, 1. All right, and from this point, left and right, we're going to move 2, but the one that counts is our up and down. So up and down, we're going to move 5. 5 up, 5 down, because those are our vertices. So our vertices are located at the points 2, 6 and 2, negative 4.
Wait.
Because up and down, we move 5. And y comes first, so those are our vertices. So up 5, down 5. Those are our vertices. Then left and right, to make the box, we're going to move 2.
Wait, what are the
Left.
verses again?
Right 2, left 2.
I know what the verses are.
All right, so the transverse axis, that's the one that connects the vertices. It's double 5, so it's 10. The conjugate axis, this time happens to be our shorter one. It's double 2, which is 4. Now,
So the conjugate's always the shorter one?
nope.
No?
This one, the conjugate was the longer one.
So what do we look
So
for?
the conjugate one is the one that does not connect the vertices. That's the transverse. All right, so now we're going to create the box. And then we're going to draw in our asymptotes. And for this, you would want to use a straight edge.
Shut up. Wait if you don't. I'm not even worried about it.
All right, so our asymptotes. The equation for asymptotes, y minus the y value. The rise over the run, up 5 over 2. So it's plus or minus 5 halves. X minus the x value at the center. Now C is The square root of, let's look at it, 25 plus 4. So c is the square root of 29. And do I add that c to the x or to the y to get the foci?
The Y.
The y, because this one opens up and down. So the foci have to be moved out here somewhere. Out up here somewhere. So we're to find our foci, now that we have c, we're going to add and subtract that to the y. And there is our foci. All right. So I passed out the homework. While you guys, whoops, I passed out the wrong homework. That one's tomorrow night's homework.
Already finished.
So hold on just a second. And I will pass out today's.
Pass them up.
No, you can hold on to it for tomorrow.
I know some people are gonna lose it.